Hey dark mode watchers, I've got a question for you. What's a single technique we can use not only to help build reliable software, but to actually validate that our software is reliable with data? In this video, we're going to learn about service level objectives, or SLOs for short. Service level objectives are quantifiable targets. They give us a vocabulary to help specify the exact level of service that we expect our software to provide. So how are we going to learn about SLOs? We'll define an SLO together based on a hypothetical e-commerce flow. Once we have our SLO defined, we'll introduce SLIs, which stand for service level indicators. SLIs are the actual measurable data that we collect from our system. The goal of the video is to help you and your team build reliable software, full stop. Okay, dark mode watchers, now that we know the mission, let's use service level objectives and service level indicators to build some reliable software together. Let's go. So you might be wondering, what are SLOs for? How do we get started? We're looking to answer specific reliability questions, like how reliable is it to create a new user? Or how reliable is it to accept credit card payment when a user is checking out? When we get enough of these operations under measurement, that's when we can truly start to figure out what the reliability of our system looks like. And the question that SLOs will help us answer is, how reliable is our system from the perspective of our users? Or framed in a different way, are we providing the level of service that our customers expect? SLOs are reliability commitments from a customer's perspective. But how do these commitments happen? In order to properly understand SLOs, we first need to understand where SLOs fit into the different phases of software delivery. We can think of software delivery happening in 4 phases: planning, implementing, operating, and understanding. SLOs always begin with planning. They're as much a communication technique as a technical initiative. At the first moment we're thinking about adding a new feature to our system or changing an existing feature, a conversation about reliability should take place. Without SLOs, this conversation might be informal, maybe too informal. With SLOs, we can not only formalize reliability conversations, but we can also put a system in place to measure actual reliability against the reliability targets that we set. Let's start learning about SLOs hands-on by jumping into the planning phase of software delivery and defining our first SLO. Imagine we're sitting in a room with a product owner, a developer, and an architect. Defining an SLO is always a collaborative exercise. Let's build an SLO together. We'll build an example SLO that might be used in an e-commerce system that sets a reliability objective for the user's experience when placing an order. We need to define 5 things. First is the operation that we want to define a service level objective for. Second is the service level indicator. Third is the aggregation window. Fourth is the target value. And finally, 5th is a summary of the complete service level objective based on the other 4 criteria. You can think of this as the final SLO summary. It'll be easier to understand when we see an example, so let's start building this out now. Operation. A new order is generated, submitted, and acknowledged. This is a customer-facing operation that we collaboratively decide is important enough to set a service level objective for. We only want to focus on operations in our system that are important to our users, which is what separates SLOs from other types of operational visibility like learning and monitoring. Service level indicator. Latency in seconds from order submitted to order acknowledged. This means that for each order submitted, we need to be able to obtain this request in our log files or from some other telemetry data. We'll show some code examples later in this video that more deeply explain SLIs. But remember that this is the actual measurable data we'll need from our system in order to be able to compute SLOs. Aggregation window. 8 hours. We'll also explain more about aggregation windows shortly, but this is a really important concept. SLOs focus on reliability trends, not individual errors. Aggregation windows should be meaningful to the business and to our users. In our e-commerce example, we can use the aggregation window to pick up on trends in our e-commerce system, like orders becoming less reliable every Monday evening. This would be a meaningful insight to our business. Imagine that we always do deployments on Monday evenings. Aggregation windows can help to point us to hotspots in our overall system design and help to increase the reliability of our system. Target reliability, 90%. This is our target reliability threshold. We'll always accept some unreliability, as building 100% reliable systems is literally impossible. We typically limit reliability targets to nines, as in 90%, 99%, 99.9%, and so forth. In a real production system, we would set this target higher than 90%, but targeting 90% as an example will make it easier to show simple SLO math later in this video. Finally, our objective. New orders are acknowledged within 1 second and achieve this level of service 90% of the time. This is our final target measurement, a succinct definition of our service level objective. To be more specific, what we discussed was a windowed latency SLI, with an emphasis on latency. In our example SLO, we're focusing on the reliability of order processing acknowledgement, and we quantify this using a measure of latency from an order being submitted to an order being acknowledged. This measure is a very important flow in our business from both a user perspective and a business perspective. But how do we handle measuring other characteristics of reliability other than latency? What if we didn't really care about the time it took to acknowledge orders, but were only concerned that orders were acknowledged eventually? The book Database Reliability Engineering outlines a few categories of SLIs. Let's go over the 4 basic categories of SLIs, starting with latency, so we can form a clear picture of all of our options. First, latency SLIs. Latency is a measurement of delay in a communications flow. This might mean the elapsed time between a request and response in terms of a RESTful API call, or it could mean the delay between a message being sent and an acknowledgement being received by the sender in an asynchronous communications flow. Latency is measured in units of time. Typically, we measure latency with a single upper boundary, like a new user account is created within 2 seconds. But we might also add a lower bound, like a new user account is created in between 1 second and 2 seconds. This can help us to avoid over-engineering for low latency when low latency isn't really required. Second, availability SLIs. Availability is a simple measurement of whether or not a service is generally available given a valid request. This can be measured using a simple Boolean. A service is either available or not. A good example of this is a simple health check API endpoint that we might add to a service. As long as we receive a pong every time we send a ping to the health check endpoint, we consider that service available. Think about an online banking system. A basic availability SLI might help us to detect trends in downtime based on releases, maintenance windows, unexpected incidents, and so forth. If we see availability start to decrease over multiple aggregation windows, we might evaluate all of the changes that have happened in those windows to help us pinpoint availability trends and the root cause of unavailability. This is easiest to quantify using a simple availability SLI. Third, consistency SLIs. Consistency SLIs are useful to help us measure the quality of data. Simply put, do users receive the data from an operation that they expected to receive? Consistency SLIs are a useful complement to other SLOs. For instance, techniques like caching might help us to improve latency, but overdoing caching might negatively impact data freshness. Imagine we return data that's so stale users think the service is actually broken, like returning a cached bank balance after a user deposits a bunch of important checks. How long is too long before the details of a deposit should show up in the user's balance and transaction history? That would be a good example of consistency objectives to discuss and put under measurement. For instance, users see an online check deposit reflected in their transaction history within 2 seconds is kind of a combined consistency SLI with a latency SLI. Fourth, throughput SLIs. It's useful to measure throughput for many high-volume systems, such as streaming platforms. This type of SLI can help us to ensure a minimum and maximum throughput for a service is maintained, such as transactions processed per second or bytes streamed per second. The way a throughput SLI is worded and measured depends on the type of service being measured. Both an overnight batch process and a real-time streaming service might value throughput, but each will measure this quite differently. While other categories of SLIs exist, these are the 4 basics. Now that we have an SLO definition and understand our options for specifying SLIs, we need to plan how to measure the real-world performance of our system against reliability targets. Implementation is the first phase of delivery in which SLOs might have a profound impact on development efforts. At the most basic level, we need to make sure that the service level indicators we identified during planning are available in our logs or another operational data source like a time series database. Beyond the basics, SLOs may have a large impact on technical design. Setting a reliability target of 99% for a new feature might not have an impact on a system's architecture or infrastructure, but setting a reliability target of 99.999% might have a profound impact. All of this impact needs to be captured in a technical design of some sort, and may influence anything from revisiting SLO commitments to contemplating long-term architectural changes needed to support increased reliability targets. When getting started, don't focus on making any wild changes to your architecture or infrastructure. The first goal should simply be getting actual reliability under measurement. This typically involves iteratively adding SLIs to code, and then making sure those SLIs can be hooked into operational visibility tooling, like Prometheus. Let's walk through a quick example of how to measure our example SLO. Given a shopping cart with items, a user clicks checkout, enters their payment information and shipping address. Remember, the SLI is the number of seconds it takes to process a valid order. We'll implement this SLI using data that's available from our log files. There are many other ways to get SLI data, like from load balancers, but for this example, log files are the easiest to explain and understand. Imagine we have a function that looks something like this. Let's walk through these simple steps. First, we validate the credit card provided. Second, we validate the address. Third, we process the order with the validated credit card and address. And finally, we return an order confirmation. Now, to actually generate service level indicators, we'll need three things. First, a log of all checkout requests. Second, a log of all successful orders, along with the latency measurement from order to acknowledgement. And finally, third, a log of all failed checkout requests. There are many ways to write and read service level indicators, but let's keep it simple and write these indicators to our log files. Our final process order method may look something like this. Don't really pay attention to the syntax. The important points are what we need to log. First, we'll log a tally of all checkout requests. Second, we'll create a timer for the entire checkout code block. Third, we'll log all successful checkout requests along with the latency that we measured. Fourth, we'll log all validation errors. And fifth, we'll log all service errors. Pay special attention to steps 4 and 5. We decided to distinguish between the validation errors and the service errors. We made an assumption when first defining this SLO that the user is going to provide valid address and payment details. If they don't, the validation methods will throw a validation exception, which we log separately from other errors. This gives us the ability to ignore these types of errors from the total request tally and not factor user input errors into overall SLO performance. In this phase of development, it's clear to see that when we implement a feature or change existing code, we should do so based on some type of plan. That plan should include SLO commitments, and most importantly, account for the specific SLIs that we'll need. Now, let's cover the next phase of software delivery and how it relates to SLOs. Operations. Hey, welcome to the fun part. After we've defined our SLOs and implemented the required SLIs, we're ready to hook up those SLIs to some type of dashboard. Ultimately, we want to visualize our SLO data, report on SLO performance, and perhaps even export SLO data to other analytics tools. The most typical step at this point is to create a Grafana dashboard in order to visualize SLO performance. To report on metrics-based SLIs, such as those captured by the monitoring system Prometheus, we can start with a quick look at an SLO tool called Sloth. Sloth takes simple SLO spec files and turns them into generated Prometheus rules. This saves a ton of time when implementing SLOs compared to hand-coding your own Prometheus rules. Sloth has a bunch of built-in SLI plugins to help accelerate building simple SLO dashboards based on availability and latency metrics, from tools like Core DNS, Istio, and Kubernetes. One cool thing to point out is that if you use Prometheus, you can also alert on SLOs using something like Prometheus Alert Manager, and fire off those alerts to Slack or a pager tool of your choice. Let's assume we'll use Sloth for now to build a simple dashboard. Every Sloth SLO specification contains metadata details, including the SLO name and objective, along with SLI data, which we've already discussed. This is an example Sloth spec, which is a YAML file that we would use to programmatically define an SLO dashboard for Grafana. This is a simple example of HTTP availability. Don't worry if the syntax seems arcane. We'll cover simple SLO math shortly that should make it easier to understand how reliability is computed within an aggregation window. Now here's the SLO dashboard that we generated based on that spec, shown in Grafana. This dashboard displays the reliability of a home's Wi-Fi connection. There are really no limits to what type of service level objectives you can define, as long as you have SLI data available. But what about aggregating SLIs from log data, like we demonstrated in our earlier code example? Writing time series data to our logs that represents SLIs is a really typical starting point for legacy applications. Unfortunately, Sloth and Prometheus aren't exactly the right tools in this use case, as Prometheus isn't really meant for log data. However, there are workarounds. One simple workaround is to use a logging library that integrates with Prometheus, like Log4j2. This allows you to specify a Prometheus endpoint as a log output, which will send the logs to Prometheus, enabling Sloth to generate SLO rules. A more popular tool for implementing SLIs with legacy application logs is Loki, which can be thought of like Prometheus for logs. The good news is that Grafana supports both Prometheus and Loki. You can use Grafana to create alerts based on data from both systems, using the Prometheus Alert Manager for metrics-based alerts, and the Loki Alert Manager for log-based alerts. Using Loki and Grafana is slightly more complicated than Prometheus and Sloth, but we can describe the process in a few basic steps. First, you'll need to configure Promtail to scrape log data from the specific log files that contain the data that you need to track your SLIs. This can be done using a Promtail configuration file. Next, you'll need to define parser configurations that extract the relevant data from the log files and send it to Loki. These parser configurations can use regular expressions to parse the log data and extract only the desired fields. Once you've defined parser configurations, you'll apply them to the log streams. Next, you'll use the Loki query language, LogQL, to extract the data that you need to calculate your SLIs from the extracted fields. For example, you might write a LogQL query to count the number of checkout requests with the successful status code and latency under 1,000 milliseconds. Then you can create a separate query to count all checkout requests, and both of these can be used to compute your SLOs. Finally, you can use Grafana to create graphs and charts based on the log data you've queried to track SLIs over an aggregation window and compute final SLO results. There's certainly more configuration to do to configure aggregation windows properly, but these simple steps should point you in the right direction. One challenge worth mentioning around using Prometheus for SLIs is the limited retention period. If you have a lot of time series data to work with, a project worth checking out is Thanos. It's an open source HA Prometheus setup that aims to provide unlimited retention options. Thanos was built to transform existing Prometheus deployments into a unified monitoring system with unbounded historical data storage. Finally, if you're just looking for the most simple way possible to get started with SLOs, there are completely turnkey options out there. One worth checking out is Noble9. It's basically a turnkey platform that lets you build service level objectives from existing monitoring. I'll link to both of these tools in the description. We'll now cover basic SLO math in case you have an interest or a use case to implement a more custom aggregation and dashboarding solution and need to build something bespoke to compute SLO results. Let's imagine the following scenario. In an 8-hour window, or aggregation window, we have 110 total checkout requests. 10 of those requests fail because of a user input validation error, leaving us with 100 requests to consider. Remember that we expect the user to provide us with valid data, so we don't consider validation errors. 10 additional requests fail because of a server-side error, which might include any other exception, including service timeouts. We haven't specified any special handling of server-side errors, so we do take these into account and treat them like any other failure. 2 requests succeed and return a result, but are slow and take over 1 second to complete. We also consider these to be failures. This leaves us with 88 successful responses that are returned within 1 second. We achieved an 88% actual success metric for this window, which is just shy of the 90% we aimed for. We would report that we failed to meet our SLO during this aggregation window. However, it's important to note that this was a combination of a latency SLI and an availability SLI. This is because we consider both server failures, along with slow responses, as failed requests. If we want to be razor sharp about measuring for latency only, we would also need to subtract server failures from the total request tally and only consider the latency of requests. Let's change the formula to reflect this. In an 8-hour window, or aggregation window, we still have 110 total checkout requests. 10 of those requests fail because of a user input validation error, leaving us with 100 requests to consider. Remember that we expect the user to provide us with valid data, so we don't consider validation errors. 10 additional requests fail because of a server-side error, which might include any other exception, including the timeout of third-party services. This time, we exclude these errors from our measurement to avoid conflating latency with availability. 2 requests succeed completely and return a result, but are slow and take over 1 second to complete. We consider these to be our only latency failures. This leaves us with 88 successful responses that are returned within 1 second. However, this time we only have a total of 90 requests that we consider under measurement. This means we achieved an outcome of 97%, exceeding our goal of 90%. What a difference! Now we defined a strict latency-based SLI, and we would report a success within this aggregation window. We're now at the most impactful phase of the software delivery lifecycle related to SLOs, which is the phase of understanding. Periodically, whether we're talking monthly, quarterly, or annually, it's important to understand how reliable our software is. At some point, we should review SLO performance against targets. This could be wrapped up in some kind of executive report and shared with the executive team. Regardless, keep learning. SLOs provide the actual raw data needed to have a data-driven discussion about the reliability of the software that you're building. Remember that actual real-world SLO performance can influence future plans, designs, and strategy. Then, the next time we're sitting down and making future reliability commitments, we can actually look at past reliability achievements and make really concrete, data-driven decisions. A concept that we haven't yet covered is the SLO burn rate. Imagine we set a target of 90% reliability for an SLO, but we actually achieve 99.9%. That means we have a large remaining quote-unquote error budget for the current month or the current year, and we might be able to use this excess budget to implement some kind of nice-to-have change. If we're actually failing to meet our reliability targets, we shouldn't do anything except improve reliability. But if we're outperforming against reliability targets, this is the time to take on that ambitious new feature, refactoring, or some other kind of optimization. Error budgets are an advanced SLO concept, something that really not a lot of teams are actually doing, and one that I don't recommend that you worry about if you're new to SLOs. Get SLOs in place, start collecting data, and maybe visit error budget sometime down the road as a future improvement to an initial rollout of SLOs. With the type of reliability planning, development, operational visibility, and reporting that we've already discussed, you'll be way ahead of the game, even without error budgets. I have a feeling that we're about to hear an objection.
Actually, we don't need SLOs. We've been building reliable software forever.
You're right, you don't need SLOs. But before you write off SLOs, ask yourself if you have reliability evidence. Can you boil down reliability to numbers? Do you regularly meet to discuss reliability, look at old objectives, and align on new objectives? If you do all of these things, you're actually doing SLOs. You might just call it something else. That's totally cool. SLOs provide reliability evidence that can actually help us change our plans. If our software isn't reliable, maybe we should turn away temporarily from our long-term roadmap and start thinking about increasing the reliability of a feature or a component. If your organization's at the point where the software it's producing is important enough to be reliable, you need a plan. But if you have a reasonable software development process in place already, SLOs are a great technique for helping to increase the reliability of the software that you build. If you're interested in learning more about SLOs and SLIs, there are literally dozens of books out there that can help guide you in the right direction. I recommend taking a look at the book Implementing Service Level Objectives by Alex Hidalgo as a good first place to start. Google also has a ton of videos on more infrastructure level configuration options, like pulling SLIs out of load balancers and pumping SLIs from other parts of your infrastructure. I'll leave more links in the description that point to more learning resources that you might find interesting. I hope you enjoyed the video. Now have one extra tool in your toolbox for building reliable software. SLOs and SLIs are one piece of the reliability engineering puzzle, but one of the most important. They give us a framework for communicating not only within technical teams, but across an organization. With that level of communication, there's really no stopping us. We can build reliable software that's as solid as a rock. Thanks for watching, and remember, turn dark mode on, because nobody wants to pair program with a light mode coder, and stay tuned for the next video.